Welcome to Arizona State University's University Academic Success Program. This is an example video for the topic Finding Z Scores and Probability if something is greater than the Z score. Z score is standardizing the information to fit one normal model bell curve with a mean of 0 and a standard deviation of 1. Each type of score goes with their own model or distribution. You will be learning many different distributions throughout the semester.
Why do we need to standardize?
When you're standardizing, you can find probability or probabilities of a number happening with a table or tables and programs without needing to use calculus.
Can we do an example?
Let's say we have this problem. D has an average of 30 miles per gallon with a standard deviation of 3 miles per gallon. What is the probability that D will get 40 miles per gallon or higher for a tank of gas? A little side note, this problem was made up and will not be able to be found in a book or a website. First, we need to find a score. We can find many different scores depending on what the question is asking for. For today, we will be using the Z score. We now need the formula, and the formula will be Z equals X, the number we're looking for, minus the mean, in other words, the average, all divided by standard deviation.
I thought X was the sample mean.
Close, but X bar is sample mean. When we're working with Z, we have mu and not X bar. X bar is the X with the line over it. So we can substitute all the numbers in for our Greek variables or regular variables, and we will be looking at 40 minus 30 divided by 3. We will get the result of 3.333 going on forever. We want to round to 2 decimal points. For the Z score and using the Z table, the statisticians tend to round this specific set to 2 decimal points. We have 3.33.
Cool. We are done then.
No, we are halfway done. We have the Z score. This next part, to find the probability of 40 gallons per mile for a tank of gas or higher, can be done in many different ways. Today we're going to use this Z table. Now we are looking at the first column on the left side, and we will find the whole number in the first decimal point. We are looking for 3.3. And that's close to the bottom. We found it. We are looking at the first row on the top for the second decimal point now. And that will be for us 0.03. And we will find where the row of 3.3 and a column of 0.03 will meet for the percentage. But we need to remember with the Z table, we're looking at less than the Z score. But for the problem, we're looking at greater than the Z score. I know. We are not done, but we're almost done. Less than is equal to 0.9996. Now, we have less, which is great, but we need greater than. Less than and greater than are opposites, so we're going to do 1 minus the probability of less. And now we can do 1 minus 0.9996, and we will get 0.0004.
A friend told me about this shortcut where I use the same number but with opposite signs. Will that work?
There are shortcuts that a lot of students like to use. But the best practice is not using these shortcuts and doing 1 minus the probability, because the shortcut does not work for all distributions you're going to be learning.
How can we word it? My teacher wants us to use only words, not the percentage.
There are many ways we can do this, but one way is to say this. There is 0.04% chance that D will get 40 or higher on our gallons per mile.
Okay, let me see if I remember. First I need to find the z-score. Then with that I need to find the percentage/probability. Then if it is greater than, I need to do 1 minus the probability that I originally found. Is this correct?
Yes, and also, while working on problems like this, here are some things to keep in mind. 1. Know what distribution you are looking at. 2. Knowing the correct score formula we need to use. Knowing if we are looking at less or greater than. If we're looking at greater than, do 1 minus the probability of less. Also, knowing what your teacher wants you to use and what you will be expected to know how to use on the test. Thank you for coming and asking questions.